Study of gas laws. Today we'll discuss Boyle's law. Sir Robert Boyle in year 1662 studied the relationship between the volume of a fixed mass of an enclosed gas at a constant temperature by increasing or decreasing pressure on it. He found that on increasing pressure, the volume of the gas decreases and vice versa. This behavior was generalized and named as Boyle's law, which is stated temperature of an enclosed mass of dry gas remaining constant, its volume is inversely proportional to pressure. To understand this, let V be the volume of an enclosed dry gas and P is its pressure such that temperature is constant. So volume is inversely proportional to pressure at constant temperature. V is equal to K upon P. Here K is constant of proportionality. Hence PV is equal to K. If temperature of a gas is kept constant such that its pressure changes to P1 and then P2, when corresponding volumes are V1 and V2 respectively, then according to Boyle's law, P1 V1 equals to K. This is written as equation 1. Similarly, P2 V2 is equals to again constant K. This is equation 2. By comparing equation 1 and 2, we have P1 V1 is equal to P1 V1 is equal to P2 V2. The above relation is called Boyle's law equation. From the above equation, the Boyle's law can be defined as temperature of an enclosed mass of dry gas remaining constant, the product of its pressure and volume is a constant quantity. Table of experimental data for the validity of Boyle's law. Here in the table, pressure and volume values are given and their product is given. If pressure is in centimeters of mercury 10 and volume in liters 2, then product is 20. If we decrease the volume and it becomes 1 liter, then pressure would increase, it would become 20 and product would remain again 20. If volume further decreases to 0.67, then pressure would increase to 30 and product would again be approximately 20. And if volume further decreases to 0.5, pressure would become 40 and the product would again remain 20. Conclusion: The product of pressure and volume P into V is a constant quantity provided that the temperature is constant. Now curve between pressure and volume. Here pressure is inversely proportional to volume as now curve between PV and V becomes straight line. Curve between pressure V and volume 1 upon. These are isotherms. Temperature T3 is greater than T2, which is further greater than T1. Isotherm, a curve plotted between pressure and volume at constant temperature is known as isotherm. Example: the size of weather balloon keeps on becoming larger as it rises to higher altitude because at higher altitude the external pressure, that is atmospheric pressure on balloon, goes on decreasing and the size of balloon increases. Now we'll discuss some questions on Boyle's law equation. Example 1. A gas occupies 1500 centimeter cube at pressure of 720 mm of Hg. Find at what pressure its volume is 1000 centimeter cube. Assume temperature remains constant throughout the experiment. Solution by applying Boyle's law. P1 V1 is equal to P2 V2. Here P1 initial pressure is 720. Initial volume V1 is 1500. Final volume V2 is 1000 and final pressure has to be calculated. So P2 is equal to P1 V1 upon V2, and substituting the values, the final pressure comes out 1080 millimeter of mercury. Let's discuss another question. At constant temperature, the volume of a certain gas was found 800 centimeter cube when pressure was 760 millimeter of mercury. If the pressure increases by 25%, find the new volume of gas. We know here initial volume V1 is 800, initial pressure P1 is 760 millimeter of mercury. Increase in pressure, that is 25% of the initial pressure. which is equal to 190 millimeter of mercury. Hence, final pressure P2 becomes 760 plus 190 equal to 950 millimeter of mercury. By applying Boyle's law, P1 V1 is equal to P2 V2. Final volume V2 has to be calculated. So V2 is equal to P1 V1 upon P2. On substituting the values, final volume V2 comes 640 centimeter cube. On substituting the values, final volume comes 640 centimeter cube.